All right, here we are with another example on a hypothesis test for two means. We wish to test the following claim at the significance level of alpha equals 0.001. So I'm going to go ahead and put that over here. Whoops, blew up the wrong side. So alpha, I think I said 001, but I think there was a 5 there. Yeah, here it is. Okay, we've got mu sub 1 is equal to mu sub 2, and the alternate hypothesis that mu sub 1 is less than mu sub 2, so this is a left-tailed test. Remember, you kind of follow if you got the arrow going to the left, it's left-tailed. If it's not equal to, it's two-tailed, and if the arrow's pointing to the right, greater than, is right-tailed. So, you obtain the following two samples of data. You need to figure out your test statistic, p-value, and make a decision here. So, go ahead and put sample 1 here, and I'll grab sample number 1 and paste it special, and then over here we'll talk sample 2 and grabbing that, and I will paste special text. Here we go. So n sub 1 and sub 2. So I'm going to count these guys up, and I got 39 plus another 12. Seems like 51, so here it is, 51. Just making sure grabbing it doesn't matter. And 41 here. Now we need x bar sub 1, which I'll just call x sub 1, and s bar sub 1, also x bar sub 2, and s bar sub 2. And I just changed that x bar sub 2. Go ahead and move the bar, switch it back. Okay. We'll start with this one. We're over here. Grab the average. That's our x bar. And the standard deviation. Again, we have samples here. Standard deviation dot sample. Grab that stuff. And there we are. Average. I gotta get over here so I can grab them all. And standard deviation of the sample. Making sure I get them all. So now we've got our n sub 1, x bar sub 1, s bar sub 1. So I'm going to make my fancy fractions. So fraction 1, I like to call it, and I really like to not actually put the 1 in first. It is the sample standard deviation quantity squared divided by n. And then similarly, we'll do something like this for fraction 2. And again, that's s bar sub 2 quantity squared over n sub 2. And we use those really to figure out our standard error and eventually our degrees of freedom. So it's the square root of the sum of these. So this guy plus this guy. And maybe I should just make this larger to give us some room here. So that's our standard error, and that's right here. That's where we get fraction 1 and fraction 2. And then we can figure out our test statistic. Don't know why I put an equal sign there. Doesn't quite work. So I need to open some parentheses because I need to do x bar sub 1 minus x bar sub 2 and then divide by the standard error. Now sometimes people draw the picture first, and I suppose if you're clever here you could sort it out. If I take this guy minus this guy, it's going to be negative, but I wasn't thinking about that all too much here. So now I've got my test statistic with this ugly scribble. Negative 1.5 is over here, and we are left-tailed. That's a pretty ugly 0.5. So it's going to be this stuff is my p-value. But before that, I need to figure out my degrees of freedom. For my degrees of freedom, I've got to figure out what's in the numerator. And the numerator is my fancy fraction plus my fancy fraction, and that quantity gets squared. So I'm going to add this fraction and this fraction and then square it. And then I also need the denominator. And the denominator, I have 1 over, I have to do n sub 1 minus 1. And it gets multiplied by our fancy fraction, but it's actually squared here. So I got my fancy fraction squared. And then I've got to add 1 over n sub 2 minus 1. Close that parenthesis, and then I've got my fraction 2 squared, and should be good to go there. Last time I got a little barking about some parentheses. Okay, so all of this lets me get to my degrees of freedom, and the degrees of freedom is this numerator divided by the denominator. Okay, so now lastly, maybe not quite actually, but p-value. Our p-value is a t-distribution. This is left-tailed, so I can just use a t-distribution. Go ahead and grab my test statistic and my degrees of freedom, and then throw out true here, and there we go. So I'm going to go ahead and maybe put this back over here, see if it'll allow it, and scroll over a little. Start punching in some values here. Negative 1.5193. And then my p-value 0.066, and it's another 6 followed by a 7. No, it's followed by a 6, so it's going to round to 7, excuse me. We're comparing this to alpha. Our p-value is greater than alpha, and so we fail to reject the null hypothesis. Again, you have lots of details along the way, but this is a process that we've done a couple of times, and the overall process a lot of times. So again, I would highly recommend showing your work in an organized way. If you do it this way, it works out really well for me, because that's kind of what I'm expecting. You are expected to do the work the way it is instructed in the class, so please keep that in mind, and the harder it is to translate your work, the less likely you are to get partial credit if you miss it. If you happen to have questions and you want me to work through something, feel free to send me your spreadsheet, and I can take a look at those. And good luck. Let me know if you have any questions.